Okay, this is problem 1995, number one, and you have a block. It's moving at 3 meters per second to the right. It's moving towards another block that is 1.3 kilograms, and it gets pushed. Both blocks push up against a spring that has a spring constant of 100 newtons per meter. So that's basically the problem. They want us to find for this mass what is the momentum, and it's linear momentum. So just the momentum in a straight line. To do that's really easy. We can use our equation. P is equal to m times v. We know that our mass is 0.2 kilograms. We know our velocity is 3 meters per second. So when you multiply the two together, you should get an answer of 0.6 kilograms times a meter per second. Remember, that is the unit. It's important that you put it. So that's 2 points for that part. The next part wants us to determine the kinetic energy. So we'll go ahead and take a look at the kinetic energy of this one. So for kinetic energy, you remember the equation. Whoops, we got to get back down here. You remember the equation for kinetic energy is just K is equal to 1/2 mv squared. So we'll write that in. K is equal to 1/2 mv squared, and this is just for the first block. So this is 1/2 of 0.2 times 3 meters per second squared. Don't forget the squared. And your answer here is 0.9. And remember, for energy, our unit is a joule. So far, so good. Next part of the problem is it says determine the following for the combined masses immediately after the impact. So the first thing that we have to do is we have to remember that the original mass, the original momentum, if we remember, was equal to 0.6 kilograms times a meter per second. And for this one, the original momentum should be equal to the final momentum, and that's just the conservation of momentum, just like we had the conservation of energy. So if that's true, our final momentum is equal to 0.6 kilograms times a meter per second. So pretty simple to do. The next part's a little bit more difficult. We've got to do a little bit more math with it. So let's go ahead and take a look at the next part. So for the next part, they want us to find the kinetic energy of the whole thing. So to find the kinetic energy, first thing we have to do is we already know the final momentum. So we said the final momentum should be equal to the final mass times the final velocity. So here our final velocity should be equal to the final momentum divided by the final mass. And if you remember, in this problem, we don't have one mass in the end. We have two masses that are now stuck together. So we have a 0.2 kilogram mass and a 1.3 kilogram mass. So when we find the kinetic energy after the impact, we really need to find the speed of both things as they're moving together after the impact. So what we'll do here is we'll go ahead and put in our final velocity should be equal to our final momentum, which we said was 0.6 kilograms times a meter per second, and then our final mass, which is the bigger block plus the smaller block. And if you do that, you should end up with a final velocity of 0.4 meters per second. It's important that you have that 0.4 meters per second. So that's 1 point. The next part of this is worth 2 points. We know the final kinetic energy is equal to 1/2 of the final mass times the final velocity squared. We know that that's equal to 1/2 times, now the final mass we said was 1.3 plus 0.2, so that'd be 1.5 kilograms times 0.4 meters per second, but we have to square it. And so our final kinetic energy here is 0.12 joules, and that's worth 2 more points. So pretty easy problem to do up to this point. There's a little bit more to it, but we'll skip it and go on to it at another time.